Good afternoon, everyone. My name is Rossanan Aiyala, and today I would like to talk to you about gut content and feeding habits of Oreochromis niloticus or Linnaeus. My talk is divided into four parts. I will begin with introduction, then I will look at feeding habits, next gut content, and finally conclusions. I will be glad to answer any question that you may have at the end. I will start with some general information on Oreochromic niloticus. Oreochromic niloticus, also known as Niloticus or Linnaeus, belong to the family Aiyala, which is a tropical freshwater and insulin species of high economic importance and a generalized omnivore. It thrives well in shallow, still water and in correlated areas of lakes and rivers. Right, let's move on to feeding habits. Niloticus is omnivorous where phytoplankton, macrophages, insects, distincts, and zooplankton were the most important food items. It has a versatile feeding behavior characterized by generosity and opportunistic omnivorous feeding behavior. The small size group highly prefer to eat the animal origin foods, and the larger group mainly feed on phytoplankton, detritus, and macrophages. They are shifting from omnivorous feeding habits to herbivorous feeding habits with increased insight. Generally, the feeding biology of fish is depending on prey availability, season, habitat, difference, and size of the fish. This leads me to my next point, which is gut content. This is divided into three research from Arboreal Race Egypt, the Lagos Lagoon Nigeria, and Jaguar River in Java. I will start with Arboreal Race Egypt. The study of material and method are specimens more 280 for food analysis were obtained from gillnet. Specimens were dissected and their guts removed and preserved in 4% formalin, and the gut content of fish measuring 10 to 23 centimeters total length. Analysis was done choosing frequency of concurrent and numerical methods and described by Hislop. The result in concurrent method diatoms was found to be the most preferable food of plant origin where it concurrent in more than 68% of the assimilated fish. Skin algae and bluefin algae as a group contribute about 56.5 and 19% respectively. Examination of the diet of Niloticus showed that there was high percentage of detritus and sand particles. Regarding regional concurrence of the different food items in the guts of Niloticus, Figure 2 shows that a high percentage of concurrence of skin algae were recorded during both spring and summer, while the highest percent of blue-green algae concurrent during winter, and detritus constituted the highest percentage in spring comprised about 90.9%. In the numerical methods, detritus and diatoms form the most important diet. Seasonal variation of different food items show that diatoms form the most important food item of plant origin during the fall season as shown in Figure 3. Next, the Lagos Lagoon Nigeria have material and method a total of 480 right Oreochromic niloticus were collected from Lagos Lagoon. The feet were dissected to remove gut sample and the gut content were fixed in 4% formalin prior to examination. The various items in the feed guts were analyzed using frequency of concurrent, dominant, numerical, volumetric, and relative index methods to show food items prominent and important. The result, the gut content of tilapia include phytoplankton, insect parts, plant parts, sandgrass, and some unidentified food items. Table 1 shows percentage concurrent of gut content of tilapia from the glagus. Phytoplankton ranks highest in concurrent of food items in the glass of the fish with a percentage of 62.32%. From Table 2, percent frequency of concurrent reveals that plant parts was the highest and also dominated the food item with a value of 58.54%, which is a basilariophysy length circle design food item. The result in Table 3 identified basilariophysy and the most desired food item, and admit all the methods chosen. This derives similar output of the varying methods chosen to assess gut content of the feed. The lead design food item is instead remain with as relative index amount 0.04. Figure 4 shows the percentage concurrent of food item in the gut of Oreochromis niloticus from Brachus lagus. Basilariophita were the highest, indicating that the feed highly desired this food item. Hence, the result reveals that tilapia is a generalized gasser with higher relative index recorded in pan-salt food items. And finally, Jungle River in Java. This material and method are tilapia fish was taken from local fishermen in this station. The fish was then set at the research site in order to remove its gut. The gut preserved with 4% formalin. The frequency of fish concurrent in tilapia guts in Station 1 was presented in Figure 5. The higher frequency of chlorophyta division with a percentage of 49.55%, and the lowest was cyanophyta division with 6.82%. Chlorophyta is phytoplankton that has the most genera compared to other types of algae in fed water. The percentage of phytoplankton present from T division indicated similar results: Chlorophyta, Chrysophyta, Cyanophyta, and other fish types on Figure 6. The amount of phytoplankton consumed by tilapia is thought to be in accordance with the number of types of phytoplankton in the water. The highest frequency of phytoplankton found in tilapia guts from Station 3 was Chlorophyta division. Then this was followed by Chrysophyta division, Cyanophyta division, and other types of fish on Figure 7. The higher percentage of fish type of tilapia from Station 3 was still from the Chlorophyta. I would like to conclude by the major food of tilapia were detected diatom, skin algae, animal derivative, sand particle, rotifer, and others, so the ability to exploit different variety of food items make tilapia to be omnivorous. So, study on natural feeding of fish may permit to identify the trophic relationships present in aquatic ecosystems, identify in feeding composition, structure, and stability of food web, and reference. Does have anyone have any questions? Thank you all for listening.